talking myself back into doing tons of math all day.
Connecting,
I'm
excellent
interested in that, but
connection.
you still need to do,
Seems
you
to
don't
be.
need to, but
Oh,
for
yeah.
your job, you still need a CPA certification or CFA.
Yep, looks like it.
See it popping up.
If I could do that, but I didn't love it by the time I finished it. I was like, well, I'll try this. So, it's interesting so far. And then,
Yeah, a lot of people jump into programming. We have two people who study something else.
Yep, we're on.
Earlier
We're
in
live.
design.
All right.
combined skills later, maybe.
All right. Hello, everyone out in the world of, I guess, the internet. We're going to be sending a link out for the online portion of this. And we're just finishing up our pizza, so give us a few seconds and we will be fully ready to go. Send out that link.
I haven't studied economics. I'm pretty sure you've got a good statistics background, right? So you can go into data analysis, very good field right now. Or data science.
Yeah, I'm decent at that too. I did during COVID, I did an online course. It was one of those capacity ones where you take information, like you use an Excel spreadsheet with like sales information for various stores, and then you use like Tableau or other software to visualize it, find the best location for the store, right? So business problems like that.
There's a lot of demand for that. Or business, like being a business analyst.
Yeah.
Because a lot of people don't have that programming. Data analysis, a lot of math background. There are a lot of math background persons, but having that edge is very important.
Yeah, it'd be good to be like kind of the go-between between the programming side and the business side, because there's always a disconnect. I know from a few people in the industry, and then also just from observation, like in various workplaces where it's like the programming side, the business side says I want to do X, Y, and Z, and then Y and Z are impossible or something, right? And the programmer is like, I don't know what you want, right? So it'd be good to be able to do a go-between for that. How about you? What do you find most interesting?
I like the machine learning. I built a couple of models with the library in Python. It's very good. Like you can build very simple. Like they're built-in like regressions. Just put in the data and fix that. So that's what I'm looking forward to. The thing is, it's hard to get into AI unless you're really good. So on the side, I'm into like web development, full stack development. So ideally, I want to get a job as a full stack developer, and then on the side, I work on AI, machine learning, and things like that until I get to the level that
All right, we are ready.
work at OpenAI or like companies like that.
So hello and welcome everyone to our Unity night. We have the amazing Victor here today, and he is going to go through some of the basics with Unity. We are going to get our hands dirty with Unity. This is brought to you by the Bernick Entrepreneurship Center and the Peter B. Moore Changemaker Space here on campus in E212. You're welcome to stop by. It is a student space. We have some of the best chairs in the college. I would have to say in the whole college. Best chairs. And we got computers at the back for you, extra monitors, microphones, cameras. We got a green screen. We got giant Lego to play with. So I am going to let Victor get started and welcome everyone who's in person as well. I will be monitoring from the other room the chat to see if there's any questions. So if there are, I will see if I can't get those out to Victor as soon as possible. And we're also recording this, so it will be up for later use. All right. Awesome. Hope everyone
Okay.
can hear me, I suppose.
Yeah. Also, a very quick thing to everyone kind of online. We had some technical difficulties, so we're going to be flying this at the seat of our pants. So if there are any issues, as in you can't see anything or you can't hear anything, maybe turn up the microphone or something, just let us know, and we'll be checking the chat. For now, though, I'm just going to keep the camera off just for a little bit. We're going to get started now. So, hopefully by the end, so as the title kind of suggests, we're going to kind of dive into Unity a little bit. We're going to dive into the very surface of it, but hopefully enough so that so that everyone here has enough knowledge to be able to know where to continue and how to continue on their own. Unity is a simple engine, but it can be a complicated one when it needs to be. So, just give me a second.
Quick question: do you want them seeing just your slides online, or
just for now? Yes,
okay,
just at the moment. Yeah.
Okay, they're good then.
Yeah. Okay. Yeah. So Unity is a pretty simple engine to learn, but it can be a complex engine when it needs to. There's a lot of ground. I'm hoping to get through a lot of the basics so that everyone knows kind of what the ground is. There's a lot of content to get through, and hopefully we'll be able to kind of just scratch the surface of it. But there are going to be a lot of things that you might not necessarily understand. We're going to try getting through a lot of it as best as we can. So, very first thing the very first thing I'm just going to ask is actually who here has used Unity before? Okay, only one. Well, I'm not gonna count that. What about programmers? How many programmers do we have here? No, not much. Okay. All right. Well, you're all forbidden from asking any questions relating to programming or Unity. Those of you who raised your hand relating to that, I'm serious. Everyone else here, you're going to. I'm either going to want to see some hands raised, as like when I ask some questions relating to some things, or I'm going to start putting you all on the spot. Don't worry, don't worry. This is going to be an exercise, and I expect a lot of stuff are going to be wrong. The best way to kind of learn code is to just go break it down, just step by step, go very simple with it. But before we really step into code, before we go into any of that, let's first start at the very beginning and figure out how we actually install Unity. Now this because of the way this is set up, I am just going to need to just kind of switch to it. So hopefully you all can see that. It's a little bit dark. Unity is an application that you're going to need to create an account for. You're going to create an account. You're going to go onto the website. You're going to download the Unity Hub, and you're going to install it. When you do that, you're going to see a menu kind of similar to this. And so, let me just get the mouse. Sorry. Oh, yeah. So you're going to see a menu kind of similar to this. But when you kind of get started, there's a couple of things that you're going to need to do before you can actually create a project. You're going to go to the folder here. Let me just. You're going to go to the folder here. This tab, and you're going to first install a Unity version. We're going to go to official releases. Oh. Nope. Wait, why is it not? Oh, sorry. This is the versions we already have. We're actually just going to install the editor here. Let's change it a little bit. There we go. When you need to install the engine, what I would recommend you do is get the newest engine and make sure that it says LTS, which stands for long-term support. So any bug fixes, any updates, you're going to be guaranteed to actually have those ones for a long time, like years after that particular engine is out of date. But for VR specifically, when we install the engine, I'm just going to click on one of them. The most important thing that you're going to need to do is you're going to need to pick Android build support. If you want to build for a Quest device, for instance. Another thing you might want is down here. You might want to have some documentation. It is accessible in various. It's going to be accessible in various places, and it can help you out a lot. Rest of the stuff you don't really need it, and if it asks you to install Microsoft Visual Studio, do so. This is going to be your IDE. This is where you're going to be writing all of your code. You can't write it in a text document. You can't write it in it's like in a Word document. You have to use something that can specifically parse code. So we'll do that. Okay, the rest of it is just you click install, it will install it onto your engine, you'll install it on your PC, and you can kind of go from there. One quick thing though, I'm just going to go down here, is when you install Visual Studio, you want to install one more thing within Visual Studio. So we'll go to the Visual Studio installer, and that has appeared here. Visual Studio installer. When you install your version, you'll go to Modify and scroll down until you find the gaming section here for game development with Unity. The other one with C++, that's for Unreal. I have it checked off because I use it, but you won't need it if you're just going to be using Unity. But make sure you have that checked off. Just hit Modify or Apply or whatever it's going to be, and have that module kind of installed. So let me just grab that back. So once you have everything ready, we can now create a new project. So we're going to go to create. Oops. Locate rather. Sorry. We're going to actually go to projects here. There we go. And we're going to create new project. And you're going to choose 3D Core with the URP pipeline. So URP stands for Universal Render Pipeline. It is a more it's a more robust and more user-friendly pipeline if you're going to be doing it for different kinds of devices. Yeah.
Yeah, where do I install software? I go to unity.com.
Yeah. Just go to unity.com.
There's two versions that students can get. There's the student one, and then there's also the just like plain one. If you have student credentials, you can get the student one, which has some extra stuff on it. But if you just get the regular one, that's fine too. You'll still be able to do what you need to do for the hackathon with the regular version. But since you have student credentials, you can get extra stuff.
Yeah. So we'll do that. So anyways, we'll go back down here, create project. Well, you'll name it. I forgot to name it, so it's just going to be called my project. That's fine. That's okay. And it's going to build it just for a bit. I don't know why this one's taking so long to build. So we're going to switch this.
So while the project's building, does everybody or anybody who's like participating with their computers, do you guys all have the download done? Get some hands up, thumbs up, and then you got yours downloading now. You guys in the back, you're good? Perfect.
So I'm actually going to skip that one. I'm actually going to jump into one I already have open, and hopefully we could just use that one for the time being until we can create something new. Oops, there we go. Sorry, my laptop is really slow today. It should not be taking this long. Go, we'll see. Anyways, when you first open your project, it's going to look a little something like this. And I'm just going to switch. I'm just going to switch to the camera so that everyone can kind of try to see this, hopefully. So, the Unity project, when it does finally open, it's going to look a little something like this. Your layout might look a little bit different because I already kind of have mine set up in a certain way. So the main and the most important thing to do is to understand what each of these screens actually mean, because they do all have a meaning, and there's a very specific use to all of them. There are more so much the same like with Blender. If you were here for the Blender courses with Steve last week and 2 weeks ago, you'll know that you can reposition the screen. You can change the screens and you can reposition them a little bit differently, so that you can kind of change your layout. I'll show that in a second. The main screens, the main windows that you're going to have is, one of them is going to be the scene. This is going to be the area where you assemble your project, where you bring in all your assets and you put it together to make the game or make the level. You're going to have the hierarchy. This is where the scene is going to be. This is how it's going to kind of show as a detailed list how the scene is assembled. So these two kind of work in tandem. You have the project window, which is essentially where you're going to find all of your folders for all the assets that you're going to use for your game project. So if say we had Pizza Bird here, which I don't know, Virginia, do we have Pizza Bird as a model?
No, but we have the four-legged goose.
All right, well, okay. Well, let's say we had our let's say we had a four-legged goose, and we had it as a 3D model. If we wanted to use it in game, you would find it first within your project. You then drag it out and bring it out into your scene, and that's where you would have it. And that's where you would have it for. And that's where you would be able to start making the game. Lastly, the very far right, we have the inspector and another tab that I put together, which is the console. The inspector is where you're going to be able to modify the values as well as see all the components of all the objects that you have in here. And I'll go over what all of that stuff means in just a moment. Let me just switch actually to this. This is going to be a little bit tricky to do. The console is the same as the console is going to be the same as what you would normally see if you've ever written code in a command line, for instance. This is where you're going to have your output of different warnings, different messages, as well as all your errors. It is a very useful tab, but not one that you necessarily want to have open at all times. But once again, but if you, for example, want to, you could just click and drag it and just move it about. And much like Blender, you also have all of the windows are divided into quadrants, so you can actually you can have it floating, where it's just anywhere, or you can kind of attach it to a quadrant anywhere in the on any of the other windows. Like I said, I prefer having it here. Now, there's another tab I have. Ignore animator. That's not one I usually have. There we go. There's another tab that you usually have, and this one's called Game. Game is what is essentially what the player is going to be seeing. So game is going to be what the camera sees on within your scene. So scene is where you're going to be bringing in all your objects, and then when you switch to game, you'll be able to see it's like what the camera sees for it. So. And this is going to be a little tricky because it's very small. So before we actually start looking at all the different things that we can do with this, let's understand a certain part. Oops, nope, didn't want to do that. There we go. So. An important portion of Unity is understanding what a component is, because every game, every project is going to be made of multiple objects that house components. Now, what exactly are they? Your game object can be anything that you can imagine. Your object, like let's say that four-legged goose that I had earlier. Let's say you have that as a model, you bring that into your game, that's going to be your game object. And depending what you want to do with that object will matter based on what components you have. Those components going down further have their own properties, which house values that you can then manipulate for different purposes. So let's switch really quickly to. Oops. So let's switch really quickly to these things. There we go. So this is the new project, and I'm actually just going to. And I'm just going to switch this to a full screen so that I can see it. Full screen projector source for myself. Oops. So this is what you would. So this is what you'll normally see. It's like when you first open it. This is the brand new project that I created. Finally actually started. So, a couple of things that I like to do as a general start. I actually like to create. So I prefer having a one-line column for it. I like to move the project to the side so that I have it as a bigger window. Or actually, I usually like to have it underneath here. Console, bring it. Come on. Bring the console to the inspector so that I can maximize my scene view. So, if, for instance, I want to create a cube in this scene, let's just ignore this for now, this is just a bounding volume. If I want to create a cube in this scene, we're going to have to attach a couple of components before we can actually see it. So the first thing that we'll do is we'll create an empty game object. So I'll just create that. Now if I click on the game object here in the inspector, that's why. In the inspector here, you'll have your very first component, your transform component. This holds properties for the position, the rotation, and the scale. But we don't really see anything in the screen now, do we? So we're going to have to add some components to that. So what do you think we need actually? In order to create a cube, what should we realistically have in order to be able to have a cube and scene? Like what other components do you think that we're going to need? Wild guesses.
Mesh.
Yes, yeah, exactly. We have to have first a mesh for it. So we'll create we have to create both a mesh filter and then a mesh renderer, which will allow us to have different materials for it. So for the mesh, we'll select a cube, and then here in the mesh renderer, we could give it a different material so that it doesn't have a broken one here as the pink one. Let's see if we have one. We'll create one in a moment. So let's create a material for it. So one thing you can do is within the project file, you're actually going to have a lot of different. You're going to be able to create a lot of different components for it, a lot of different parts for your project. So if we want to create a material for it, we'll right-click anywhere within our project window. We'll go to Create, and we'll scroll down to where we have Material. We'll call it a new material. Let's just call it Cube Material. Oops. Cube Material. And then over here, where we have our base color, we can double-click it, and we can change that to something, I don't know, maybe like a reddish color. And then we can take that material, and we can apply it over the cube. So now we have a cube in the scene. Let me see. Oh yeah, one thing I forgot to actually talk about, because bear with me, the screen I have on my laptop is so small, just simply because I don't have another monitor I can actually use. So bear with me, I'm going to forget a couple of things. But one thing that we need to go over is how you actually navigate around the scene, because there are different keyboard shortcuts and ways that you can move around in this. So, like Blender, I would highly recommend you get a mouse. you can use a trackpad in order to move around with the scene. It's not exactly the easiest thing to do. Even the cheapest mouse, go to Goodwill, buy one for $3, is going to do you a lot better than this than having to use the trackpad. Because of some of the buttons that we're going to have to use both on the mouse and the keyboard. So to move around the camera, like our view camera, you right-click with your mouse and can move around. If you're holding the right button and then you push any of the WSAD keys, you can move around the scene. So we can actually rotate around our cube. We can go down, up, wherever. If you click and hold the middle mouse button, we can pan the scene. And the left click is for selecting. A couple of other things. If we are moving around, if we use the scroll wheel, we can increase or decrease our speed, our movement speed. So if you want to do more precise placements, you can decrease the speed to something really small in order to get a slower movement. And finally, if you want to just increase the speed for just to be able to move somewhere really quickly, you can press and hold Shift while you're doing all of this. On the side of the screen, on the top left of this window, you'll notice we have a couple of options here. Let me actually just deselect the cube. And these options here allow us to be able to are different kinds of tools that allow us to manipulate the object. So if I was to click on this object, right now I have it set to the transform tool, to the movement tool. So if I click on any of these arrows here, I can move it on. I can move the block on different axes. So the X, Y, and the Z axis. You can also change that. You can also get this by both pressing here, or by pressing W. If you press E, or the next one, you'll get the rotation. It's much in the same way, rotated on 3 different axes. R is for scaling, so we can scale the cube on different points. If you click on the box kind of in the middle there, you can scale all of it unilaterally and equally. Now, if you press T, you'll get another one. And this is a little bit of a strange one because you're looking at this and if you click on it, it's kind of scaling the object much in the same way that we had with the scaling tool, but it seems to come in a weird, strange way. And this is because this is kind of by changing the bounding box of not so much the scale, but the size of the object. And while you don't really use it so much for 3D objects, you do use this a lot for 2D objects. So UI elements, for instance, we'll use this one a lot. So we'll kind of get back to this one in a moment. And finally, if you press Y, you can have all of them all at once. So if you like having all the different gizmos all at once, you can just press Y and play around like how you want to move your object. But we're going to switch back to the transform tool. Oh, and if you press Q, then you can actually just instead of having the middle mouse button, you can just pan around with by just using the pan tool. So let's get back to our components now. Now that we've kind of determined how we can create an object, let's actually do something more with this. Let's add some more components. One of the things that you might want to do with a cube is or with any object, is you may want to add a collider to it. You may want to have it so that the object can collide with other objects. And I'm just going to create a very quick object. I'm just going to create a plane. Make sure that we have the plane underneath. And we do. So we'll go here. So we'll now go to the. We'll click on the cube. We'll go to our component here for a physics tab, and we'll add a box collider. Now that we have a box collider, the object now has a collision point. And this leads now to one other extra tool that you have that has now appeared here. You can change the scale of the bounding box that you have for the collision. So if I click on it, you can move around like how big you want the you want the collider to be, or how small you want the collider to be. It doesn't have to be the same as the mesh. If you don't have this tool here, you can always just bring it up here. So you can just click on the box collider component. You can click on that, and you can move around, and you can rescale that as well, and then set it. I'm also going to go down to the plane, and I'm actually going to create a collider for the plane as well. Or does it have? Oh no, sorry, it has already a mesh collider. So we have a cube. It's kind of floating over the platform. It's not really doing much. Why don't we add some physics to it? Let's add some gravity. Let's actually see that this collider is working, that it is actually going to do something. For adding physics, for adding gravity, being able to have a velocity on an object, what you need to use is something called a rigid body. And when you add a rigid body, you'll have a couple of properties here that we're going to touch upon a little bit more, like in depth, a little bit later. But one of the main things that you're going to necessarily use is gravity, the mass, and whether or not the actually no, we're not even going to do that. So now that we have a rigid body, we can actually now see something happening within our scene. Now we have a rigid body, it has gravity, that block is now going to fall. So we can now simulate what our game is going to be, what our most boring game is going to be. Up here, if we click on if we click on the play button here, we can actually simulate our scene. So if we click on it, scripts are going to have to compile. Oh, that was really slow. Let's see if we can get it with a proper frame rate. Let's switch back to the scene. You can see if I was to grab the object again and bring it up, because it now has a gravity, it is able to drop down, and thanks to the rigid body. If I was to take away the box collider, the cube is just going to fall through everything. So it's just purely a mesh then. Okay, but that's all well and good. But what else can I do with these components? I mean, we can create these components. We can add more components to object. We can create different objects. We can add more components to these objects. But what if I want to now create? What if I want to be able to have some sort of program, be able to reference them, be able to have a script? Maybe I want to change the scale of it after a certain condition. Well, this is where we will be getting into our coding session. And there's going to be a couple of things that we're going to be doing with this code here. I'm just going to jump into... sorry. Just going to switch back to... Just going to switch back here. Okay. There's going to be a lot. There's going to be a lot that we're going to kind of go through. There's going to be a lot that we're going to be going through this one, but I'm going to be breaking it down to the most simplest of points. So hopefully we're going to be able to kind of move forward for a lot of it. If anyone feels lost at any point, please do ask questions, because this is kind of the whole purpose of this. Yes, you can go online. Yes, you can search for different tutorials. But the idea is that we do kind of want to, is that you do want to be able to understand what those tutorials are actually showing you. So when you're going to be writing code, there's going to be a couple of, there's a very important aspect to writing code that a lot of people overlook, and that is your casings and your naming conventions for it. And what this is your naming convention is what you're basically going to be naming your code, how you're going to be naming your variables. So that's going to be kind of up to you to decide. But it's also important to give how you're going to present those, how you're going to present that naming convention, and that is going to be with the casings. Because let's say we create a variable. Let's say we want to have a variable called number of pizzas, because I'm hungry. If we were to write it out in the normal way that we would have probably thought about, this wouldn't exactly work, separating out each word to create a variable. And the reason why we wouldn't be able to use this is because of the spaces in between the words. What the spaces will be seen by the program as another line of not another line of execution, just as another part of the line. So if, for example, we were declaring a variable, number would be what would be seen as the variable, then of and pizzas would be something that the code can't understand. So you think, okay, so we'll remove the spaces and we'll just slap it all together. And while you can use it, it's not exactly the nicest thing to read, especially when you're going to have a lot of lines of code and you're going to have a lot of variables. Having everything be lowercase, all kind of slapped together, is not exactly going to be nice on the eyes. So this is why we have different cases. The first case that some people use is by putting underscores between them. And this is known as the snake case. Everything lowercase, underscores between all the words in order to eliminate the spaces. There's a variant of this. If you were to use all caps, it would be known as the screaming snake case. No, I don't know why underscores in between the words was in any way reminiscent of a snake. Maybe the whole thing is reminiscent of one, but not so much of the gaps between it. Maybe he just got stepped on. Perhaps that's why he was so upset and why he decided to scream at us. Another one that has a name equally as ridiculous is the kebab case, in which you take some hyphens and skewer them through all of your words. Generally, you'd see these ones in URLs or in areas where you can't use any uppercase letters. One that's a lot nicer, though, is the camel case. And this is the one that you're going to see quite often in tutorials and what most programmers will be using, because it's a very simple one to use and it's a very easy one to kind of read from a distance. And the way the camel case works is that your first letter is lowercase, and all consecutive first letters of each word is going to be uppercase. If we were to capitalize the very first letter, well, then you'd have your final one, known as the Pascal case. And there are two different uses for both of these cases. The camel case I generally like to use for variable names, and the Pascal case I would be using for naming my classes, methods, functions, as well, and a couple of other things. So let's get started with the very basics of code. The very first thing you're going to always learn are your variables. How do we, if we wanted to have a value, what kind of value would we be able to, how do we create a value? How do we create a number, for instance? Well, we have to create a variable that can hold that number. So the integer is a very simple one. So the int is the integer, it's a very simple one, and it holds whole numbers, or real numbers, if you're a mathematician. What do you think the float would stand for then?
Decimal point.
Decimal point? You're correct. Float is the floating point, which is essentially like saying the decimal point that moves around. The one important thing that you're going to have to remember whenever you use a float is that at the end of your number, you're always going to have to use the F. And the reason for this is that you can have a float that has no decimal, because it's assumed that there is a decimal. And, for instance, if I have 8F, so a float of 8, it could then be the same as 8.0. The idea of using a float instead of an integer is if you want to have a number that could potentially have a decimal point. Next one is bool. Bool is a very simple one. It has only two outcomes, a true and a false, or a 0 and a 1. Bool can be used for a number of things. Most commonly is if you're asking a question. Is something true or is it not? It's also known as a flag or a check. A character is the letter of the that the computer understands, and it's not necessarily just letters. It is every key. It can be every key within the Unicode library. Which leads us finally to string. What would this? Anyone want to guess what a string could be?
Combination of characters.
Combination. If we take the characters and we want to make a word, we're stringing them along. And the nice thing about a string is, even though I said that you can't use spaces in your code, you can use spaces within your string. So you could have two strings where you have hello and world, or you could put the two together with a space in the middle, and this and all of that would work within your code. So now we've kind of understood what a variable is, but how would we exactly declare it? How do we start with a variable? Well, the very important thing is way to understand it is what are all the different components that you need for it. So, in a very simple way, a variable can be declared. A variable can be broken down into four different points. The first is your variable type. So in our case is our integer. The second one is what the name of the variable is. So what are you going to call the variable, and what does it, whenever you write the name, what does that actually mean? If you're going to define the variable, as in you want to give it a value at the very beginning, you would use an operator, in this case an assignment operator, and then finally a value. Now, this is going to come into play a little bit later, but unless you're not using global variables, there is one last thing that you can do when declaring a variable. If you don't have anything written before that variable type, every variable is automatically assumed to be private. There is a protection to each of these variables. If you're writing them within a method or a function, they're automatically going to be private, and I'll get to that in a moment. But if we're declaring them as a global variable, you can also say that it's public. What would it mean what does it exactly mean to have a private or a public variable? Well, if for example, I create a global variable and I make it and I specify that it's public, it means that I can access that variable from outside of the script. So another script could access that variable. But if it's private, it only exists within that script and is only usable within the class that's within that script. Now, we don't necessarily have to use just those variable types that I showed before. Remember all of those components that we looked at before? All of those components can be accessed as variables, and much the same as the variable types before. They're very simple to call. So our transform, our collider, and our rigid body can very simply be accessed within the script by just declaring its type first. This also works for custom ones. if I was to create a custom script, I could refer to that. I could also refer to that script and any of the values that are within it. So when you have so now we have some values, we have some variables. We want to do some stuff with them. So this is where we're going to be using operators within our lines of code to be able to do different things with them. Additive and multiplicative are very simple ones. These are for adding and subtracting values as well as multiplying and dividing them. Now, question: anyone been paying attention for what the assignment variable is, or operator rather?
Double equals.
Anyone know? Anyone want to take a guess?
The equal sign, right?
The equal sign, exactly. Now, if you use one equal sign, we are assigning a value from the right side in order to the left. So if we have a value of x, for example, we are now, if we use just the assignment operator, we are now saying that that x is now equal to the value of y, in the sense that they are that y's value, that x's value has become y's value. But if we use two equal signs, we have an equality operator, where it's slightly different, where it's slightly different, but also sort of the same. We are still saying that x values is equal to the value of y, but we're not assigning anything. The only time you would ever really use this is if you have this if you're posing a question. Say if you want to compare two different values together, and you want to basically say that these two values are the same. So you'd use this in something called an if statement later on down the line about changing cases. A couple of others. Other things that you can compare with are relational, so greater than, less than, nice and simple, and conditional and conditional or, which effectively say that we can take value x and value y and do something together with them, as well as say take value x or value y. Now, why would we want to do any of these things? Why would we want to say? Why would we want to compare these values, or say take two values together and compare them with something else? Well, this is where our statements and our loops come into play. We can write a very simple statement where we can have different choices, different outcomes based on what value we actually have. So if we have an integer of x, if we have an int of x, for example, x being equal to 5, if we go through this if statement, it will we can get different outcomes based on what that value is. So the way these kind of if statements work is that we can have different we can have a lot of different conditions all written out for what we want them to be. So we can have 100 different conditions, not just the 3 I have written out here. This is just kind of to give you a very quick and dirty example. So the first, for example, would be asking you whether or not the value of x is greater than is less than 6. Sorry. And if it isn't less than 6, then we will move on to the next if to the next if question, which is why we write it as else if. And this will be comparing if it's greater than 6. If it still isn't, it will go on to the next one where we're asking now if x is equal to 6. The reason we write our if statements as if, else if, is simply because if one of these conditions are met, and we enter in any one of these sections, after it finishes, it will skip over all the remaining sections afterwards. So it won't keep checking everything afterwards. It will only keep checking until it actually finds a condition that it meets. Let's take a Boolean first. Let's take a Boolean this time around. Let's say we have a Boolean that's saying that we created a simple Boolean called is door open, and we're saying that it is true. If the door is open, okay. If if our door is open, I'll use this. Sorry. Our Boolean is door open is basically just equal to true. If we want to check whether or not it is, if we want to make that check whether or not the value is true, we don't have to use necessarily any of the operators here. We could just say for Booleans that it is in fact that the value is in fact, well, that value. It's a strange way of writing it, but it's an easy, but it's an easier way. But it's a nice way you can simplify the code. You could also write if is door open is equal to true, and the code would run the exact same way. Now, because this is a Boolean, there's only really one other outcome that can happen from this. So we don't necessarily have to write else if. We could just say else, and it will do the other condition. However, doing it this way, where you have else instead of else if. Because else you don't have to specify anything. You're just saying that if these conditions above are not met, at the very end, else this is what's always going to run. If we don't specify, if we use this, for instance, on any other variable that could potentially have different outcomes, it's always important to exhaust all your outcomes first before using the else statement at the end. Otherwise, else could mean anything. There's another loop that's going to be used a lot, and this one is known as the for loop. The for loop is one that can repeat itself a certain amount of times. And looking at it at the beginning, that makes it look a little bit scary. But it's a very simple one, and it's all things that we've already kind of looked at. So easiest way to go with it is to just break it down into parts and to just isolate different sections. So let's start with the very beginning. What did we do here? All the way up to the very first semicolon. What's the very first thing that the for loop is doing? It's initializing a variable. We're initializing a variable. We're calling it I, and then we're defining it as 0. So then the next one. The next one is the condition for the loop. What's going to happen? What has to happen within the loop? What has to happen in order for it to exit out of the loop? So we're saying that our integer I is that integer I is less than or equal to y. Y being any value that you want to put in there. So if I say, for instance, that if I put a value of 5, we can expect that our loop is going to go 5 times. And then at the end, we're saying we have to do something to that integer that we declared in order to be able to move the loop forward a little bit. So we just say I++, which is the same as saying I is equal to I plus 1. So just give me a second. But let's say we just want to have one simple condition. Let's say we want a loop to happen while something is going on. So while a condition is being met. So a Boolean, for example, while the door is open, we want something to keep happening, so that the only time that we leave the loop is when the door closes. Well, for this, we use something called a while loop, and we can. And I've added one extra part to it here, where I'm actually saying where I don't want the door is door open to be true. I actually want the while loop to run while it is false. So instead of writing is door open is equal to false, you can simplify that by adding an exclamation point, which also kind of represents not. So while not is door open. Now, we've kind of gone over different variables. We've gone over being able to store the variables, but once we actually start declaring the variables, once we start creating them, there's a certain limitation that we're going to run into when we actually start doing this, and that limitation is like how much code we can actually write. If it's for example 5 integers, then it's fine. But what if it's 100? What if we start creating so many variables that we can't keep track of them? Is there a way to be able to store multiple values within one variable? There is, and this is what are called arrays. The more eagle-eyed among you, or perhaps just the programmers, might have noticed also that I structured my my chapters in a very peculiar way, as is kind of up there in the top right left corner. And this and I did it kind of in preparation, it's like for what an array is. I kind of wrote it out in the sense that each chapter that we have on these sections is held within our variable of getting started Unity, and I'm calling them based on calling the chapters based on the element of the array. Another thing, there's also another strange thing that I did, is I called my very first chapter 0. And the reason I did that is because arrays don't start from an element of 1. They start from an element of 0. So, let's take two variables that we have. One is an integer of an object ID that I gave a value of 3, and the other one is a string with an object called object name, and it has a value of q. If we were to rewrite these as arrays, we would have to do them a little bit differently. For integers, it's a little bit more simpler. You could also do this with floats as well. We would just add the brackets. We would add these square brackets to the very beginning of it. So we'd have our public integer with the square brackets. Now we have declared it as an array instead of just. So we have declared it as an array of integers rather than just integers. Back to again to the name, and then when we define it, we can just write out all of our different values that we have. So we have 6 values here. For a string, it's a little bit more complicated. This is also going to be, and this is also how you're going to write other variables as well. You're gonna when you declare your array of variables, you're also going to have a when you declare your array of variables, you're also going to have your you're also going to have to define it you're also going to have to define it straight away, even if you don't necessarily want to add these elements into it, these values into it at the start. You're always still going to have to write that it's a new string, new variable type as the array. You can also write these arrays not necessarily. Now these square brackets, you can add these square brackets to any of the variables that you had before as well. So any of the variables that we kind of touched upon before, any of the components that we create as variables, we can also have those be as an array of variables. The only difference is you have to add those square brackets and then you also have to declare it in a very different way. Calling. We can actually we can pull out the values from this, or reference the value, or reference the values at a future time, instead of just instead of just using the using single variables. We could just get very specific values, out of this array by going by writing out our name, and within the square brackets we put in a number corresponding to what that element would be. So, if, for example, I wanted to print 2 different names out, so debug log is just something that's going to write to the console. So it's just so all this code is doing is it's just going to write 2 different. It's just going to write 2 different things that I have written here. So objects. So first is going to be the object ID, which is going to be a number value, and the other one is going to be a string. I've already inserted 2 values into it. First one's going to be element 4, and then the second one's going to be element 1. So what will the console print for both of these? So first is going to be a number, then a string. What's the console going to print? All right.
So yeah, the object is going to print the 5th element, the object.
But what is that fifth element?
Is it 33? I believe. Yeah.
So 33, and what's the string?
The string is going to be the second one, sphere.
Sphere. That's correct. It's because, and that is because it is using it will be using the 0 as the array as the very first element in the array. So you're not actually counting from 1. You're counting from 0. So if I write 4, what you're really doing is you're taking the one next to it. But say for instance we want to be able to access all of the values. Simply writing all of those numbers out for every single element in the array is going to take a while, especially if we have again 100 of it. It's going to be 100 lines of code. There must be a simpler way. So let's say we have this as a private array integer in one script, and we have a public one in a different script that wants to get to have the exact same values as these ones here. We want to be able to copy them. What we would do is we would have to create something. We would have to use something known as a for each loop, and I had to create another set of integers, their integer I being 0 at the very beginning, because I needed to move kind of. I had to cycle through it all. But what the for each loop does is that we have to declare a variable. In this case, we're going to declare it as ID. Again, it has to be the same type of the array that we're going to be using. So we say int ID in object underscore objects IDs. So what's going to happen is for every single element, because it's going to go through all of the elements that are within that array, and it's only going to end until it hits the end of it. What's going to happen is on the very first element, it's going to take the value from the private integer objects IDs, and it's going to move it into int ID. So if I wanted to move it, then move that into our other array, our public array, we could then say objects. We then call the other. We then call the other variable with the element of I, and give it and assign the and just assign ID to it, because it's going to cycle through all of them. The reason I did the integer I is equal to 0 at the very beginning of it is because there is nothing in this code to be able to change the number value that I would have to have representing that element, that array number. But let's say we have a lot of different values, but we don't know how big our array is going to be. Because one thing I forgot to mention actually with arrays is that when you declare an array, you have to know how big your array is going to be. So if you create an array of 10, you won't be able to add more to that array until you recreate it as a bigger one. So you don't necessarily have to fill all 10 spaces, but you won't be able to add more of them. But let's say we don't know how many we're going to have. Let's say we can't necessarily create an array because we don't know how many variables we're going to have because they're maybe being generated as we go along. Well, for this, we're going to use something known as a list. So let's take the string of object names that we had previously. Instead of writing it out and declaring it in the way we have right now, when we do it as a list, we would instead have to declare it in a kind of different way. The main difference is that you cannot add the values into the list within the same line that you're declaring it. You have to declare the list first, and then add the values in afterwards. Thankfully, adding them is very easy, because once you add a value, it just increments the size of the list, and you can add another one kind of on top of it. And much in the same way with the arrays, pulling one out is a very simple process, and it's a very it's a very similar process. Once again, you just kind of have to know which element within your list it is. And if we were if we wanted to copy our list to another, our for each loop is a much simpler process, because a list doesn't have to have an element, because we don't have to move between elements. We're just kind of restacking the list in a way. All we realistically need to do is we just need to create our list. We just need to create our new list and just keep adding values into it. Something I've been kind of talking about at the very beginning were classes, functions, and methods. What do any of these things mean? I'm just going to switch to this camera really quickly, because I want to just kind of go over something really quickly. When we create a script in Unity, our very first script, it's going to be empty and it's going to look a little something like this. I've put in a little bit of some sections here to kind of explain to kind of just show like where your variables would go, where your code would go. But in general, all of your code is going to be written inside of a class. We're not gonna go too deep into what a class is, or how it works, or what else you can kind of do with it, because it goes a little bit tricky, goes a little bit more advanced. So just know that all of your code, all of your integers have to be written within a class. To make things really simple for you, when you create a script, you want the script to have the same name as your class. So you create the script, it's going to have the class name there as well. So the class, you can kind of imagine being the container of where all of your code is going to go into. So as for your functions and your methods, those are going to be these kind of smaller containers where you can have more focused code, almost so to speak. It's like you can kind of focus your code on doing very specific commands. And I say functions and methods because there is a difference between the two, but not so much in C#. A function can exist outside of a class, but because the language C# can't have a function exist outside of a class, there is realistically no difference between a function and a method. But if you go online if you watch other resources, you'll hear a lot of people use them interchangeably. So just know they're exactly the same in this context. Both your method and your function is where you can kind of write your code. Write your code. So we've kind of gone over a lot of the basics. Let's actually write a little bit of code for it. So I'm just going to switch over. This is going to be a little bit tricky. Oh, gee. Oh my God. Just give me a second. Full screen. Okay. That's an interesting situation. See if I can fix this. Oh, there we go. Yep. Okay, that's working now. Good. So let's actually go and write a little bit of code for ourselves. I'm just going to switch to the other one that I had. There we go. So remember my script. I'm gonna just open that one. My script is one I created very kind of quickly, very simply, just to demonstrate that you can actually call it within it. And you'll notice a lot of the. Oh, why isn't this showing up? There we go. There we go. So, what time is it? Okay. So, some of the things that we can kind of do within our script is much like I mentioned before. We have two methods here. We have our start method and our update method, where we're going to be writing most of our code. And anything and everything up above here are our variables. This is where we are defining all of our different variables here for it. So I've just kind of written out everything, all of the different ones that we kind of shown before. So these three here, I just created an integer for speed, a boolean for use gravity, and a float for velocity. None of these are actually doing anything as of right now. But I just wanted to kind of write these out really quickly, because I wanted to show what it actually means to have these. What it actually means between having public and private variables. So all of these ones down here are technically private because I didn't give a protection type at the very beginning of them. If I was to say, let's just create a very quick boolean. Boolean is private. Why not? We'll say true. If I create a boolean here, if I just create a boolean here without giving a protection, you'll notice if I go to, I'm just going to take these out just so. If I go into our script now, what's going on? There we go. If I go back into the Unity engine, yes, there's going to be errors because that's not really doing anything. Let's create actually an object. Create a 3D. You can create a 3D object. Nice. You can create a cube easily like that. Go to the inspector, and let's attach our script to this to this cube. You'll notice I have all these different. I forgot to get rid of them. Whoops. You'll notice that I have all these different. I have all these different properties exposed here. I have speed, I have use gravity, and I have velocity. But I do not have the boolean that I created called is private, and that's because it's a private variable and it's not accessible outside of that script. And that also means that it's not accessible within this inspector. If I want to, just for myself, just for me as if I'm debugging something or if I'm just doing this just to test out my code, if I want to be able to see my boolean here, what I can do, see if I just go back to that. What I can do is I can add something that Unity allows. Within square brackets, you can say serialize field, and if we serialize the field, we can then expose the value. We can then expose the value here. Although, I think it's because I have errors. It's not compiling. So hold on a second. I removed a lot of context. Oh yeah, the transform. Actually, you know what? Good. It's a good way to. Good way to fix this right now. Unfortunately, I wasn't able to prepare this before this session. Just had a lot of work I had to go through, unfortunately. Okay, let's say we create a new. Let's say we want to access the. Let's actually do something with our code right now and do something maybe with the. Oh, come on. And do something with here within our scene. We just want to be able to see us be able to access some of the values that we have in here. So let's access the position value, for instance. Let's create a. Oh, did I not save? Oh, I didn't save it. Save, compile.
Which one of the scripts did you pick on?
So I actually created the script myself.
Oh.
So this is kind of the point where you're not necessarily going to be able to follow along with this. This is just purely me kind of opening up a previous project just so I can kind of show you this quickly because we're running out of time, unfortunately. Yeah, I would have wanted to structure this a little bit differently, but we've got unfortunately too much to go through. But anyways, let's just go to the cube. So clear that, go to the inspector. Okay, now it's compiling properly. So now, if I go into, let's say we want to create a value here that can access kind of the transform components. Where I want to be able to have this script be able to access these values here. How would I do that? Well, if we use the knowledge that we gained beforehand, we would have to create a variable that can access that. So much as the same ones like I have down here. What I can do is I can create it as a public variable because we want to be able to see it. We'll give the variable type. In this case, it's going to be the transform component. And I'm just going to call it transform. It's nice, just easy. I'm going to give it the transform component. And if I was to compile it here, I would have the property now exposed, and I could and I could add in the transform component there. So I could, so couple ways, so this is now, so now, in order to be able to access this, we've created just the variable, but to be able to access it, we need a very specific reference to whichever one we want to access. And there's a couple of ways you can do this. You can hard code this by the way I did this right now, where I kind of created it as a public variable, and I just go ahead and assign one from any of these objects that are in the scene. I can click on the component here and just drag it in and add it in there, and I would have the transform component. Or you can get it within, or you can just get it within the code. And it's that method that we're going to do. So I'm actually just going to set this to none. I'm going to go back into the code. Because one way you can get that you can get these references to these variables is if the script is attached to an object, you can get any of the object data from it. The way you would do that is, now that we've kind of created this variable, we can now write it. So we can call it. We're going to say equals to. No, not game object. No, not game object. We're just going to use something called get component. So we're going to specify that we want. So we're going to say that we want to get a component specifically within these. Within these triangular brackets. Now we have to give our component type. In this case, I want to use a transform. Give that at the end, and then whenever you finish a line in your code, you always have to use a semicolon, so that it knows that the program knows that is the end of the line. So transform. Oh, hold on a second. Transform hides inherited member. Oh, I'm actually just going to give a different keyword for that one because. Oh, that's not. Nope. Oh, yeah. That's not. Yeah. I'm just going to use a different keyword because transform is a keyword that's already used within Unity. So I just want to have that. Oh, right. I can't. Right. I can't use that. I'm just going to use underscore. Normally, it's another thing I forgot to say. The reason I use underscores for some of my variables is I usually use them whenever they're private variables so that they can stand out a little bit nicer. So actually thinking about that now, that's a really bad one to do. So I'm just going to say transform 1, just so it's not confused with the keyword that Unity uses. So there we go. So if I save that, and if I go into, oops. Going back into the pod. Oh my god. There we go. If I save that and go back into the project, if I run the project, at runtime, you'll notice that it's filled it in with the cube's transform. So using the get component the get component command, we've fitted it in with the transform of this cube. So we've gotten that component. So now that we have that component, what we can do, because we have this component, let's just say I want to access like just the position from this. I could now say transform 1 dot, and you'll get a list of different things that you can do with this. But we want to be able to add in the we want to be able to access just so within that component. So we'll just say position, and we can even get Oh, sorry. And we can even get different properties within that property. So we could even get just the x property, for example, of the position. So we could say .x, and now we'll get it. Now this is throwing me an error because I don't actually have anything for it. So I'm just going to create an int num is equal to transform one. Oh, sorry, because it's not a. Sorry, those are floats, not integers. That's it. So we can get different values from all those different properties from those components. And there's different things that we can do, and there's lots of different things that we can do with them. Basically, it just comes down to what you think you would want to do. You could access this. You could access this x property of the. Sorry. You can access the position, the x position of this cube, and change it during runtime. So instead of having it be where it was right now, we can say have it be somewhere else. So how about we just do on start? So actually, let's just get rid of this. So let's create another variable. Also another thing is when I was talking about global and local variables, all of these ones here, outside of your methods within the class, these are all your global variables. If I was to create any of these variables within any of these methods, that variable will only exist within the context of that method. So as soon as that method closes out, that variable doesn't exist anymore. And so that's why by default, every variable that you declare is automatically a private variable, because it's not accessible elsewhere. So let's do transform component. So let's create a new. Let's create a new public integer. We'll call it position x. And we'll keep it undefined because we'll define it outside. So in the start, we'll say that our not position x is equal to 1, but instead it's going to be the transform 1 dot position dot x is equal to our variable position x. Can I modify it? Oh, because it's not a variable. Oh, sorry, I did this. I'm doing this wrong. Hold on. Oh, because it's a vector 3, right. Sorry guys, I need a quick break. I've just kind of overloaded myself with this.
That's okay.
Like I said, first time doing this, so you miss a lot of stuff. And now I'm trying to go back over my notes, like in my head, like how do I get you? Because I missed one key vital thing. I'm trying to get back to that, and yeah, it's
Okay.
This is live coding.
This is it's live coding, but but yeah, teaching is something I am way out of my element in right now.
I once did a lesson for my students in JavaScript, and there was like a massive error, and I could not, for the life of me, figure it out. And I got a private message from one of the students. They're like, missing the semicolon. And I'm like, good. And I'm staring at my code because I wrote it, and I'm looking at it, and I messaged back, and I was like, what line? Because I couldn't see it because I had built the code and I was writing it. Like when I look at it, I'm all like, no, I did everything right. Like I followed my notes, I did it step by step. And then I look at my notes and I'm like, no, I didn't follow my notes. I jumped this section here and went back on it. Do you have previous code that you've written before that you just
Yeah, no, I have, that's the thing. I have plenty of things. It's just that I forgot to mention something. It's like before I actually started writing this, and now I have to go back in order to do it. And yeah, I've lost myself trying to remember all of the things that I've said.
Well, let's just open some previous code. And
Yes,
like,
let's,
go through some previous code and talk about how the code was put together.
So so what I'll actually do instead, because a lot of this kind of stuff you can actually learn from tutorials as long as you understand what that code is doing, like what the tutorial is doing. You can follow along as like almost any tutorial that you'll find online. And like maybe I'll do some tutorials on some things later on. But sorry, I'm blanking still.
Yeah, let's not get stuck on this. Open up a previous project. That
Let's let me just well, no, because it's just I'm getting caught up on the simplest code right now, and it's embarrassing me right now.
That is the key of like all of my mistakes that I make when I'm writing code live. It's usually a spelling error. I've missed a semicolon. I've missed like a basic function that I'm like, yeah, now we're just gonna call on that function. That function we haven't built yet, but are going to build up here somewhere.
Yeah. Let me actually just pause this for a second. I'm just gonna fix this really quickly.
We managed to finish all the pizza today. I'm really stoked about that. That's like
It disappeared today, did it?
there's one pizza left.
Nobody saw it. That's what's
We've got
going on
a
there.
5-cheese pizza
So
here.
it's like rock, paper, scissors, take it home?
Heck yeah. Or unless anybody else wants some extra pizza right now, come and grab it.
I'm gonna need some pizza after this. I'm just gonna say it.
We'll save some pizza for Victor. Perfect.
Yeah. Unity.
Need an extra box in case we want to split the
Excellent.
pizza in half. So what courses are everyone in? I think we got engineers over here, and then computer studies. Which program? The Lakehead or the regular? The Lakehead one? What about at this desk?
Interior design.
Interior design, awesome! You guys are gonna come in here and check out all the cool stuff that we have in a little bit. 'Cause we got 3D printers and laser cutters, and they're all student access. So if you want to build something, you can come in here, and this is where you can do that. So if you have an idea for something, or you have a school project you want to do, we've got 2 3D printers in here. We got some carbon fiber, we've got some PETG, we've got some PLA, we've got a rainbow of colors. And then we've got the 2 machines that run. One runs on a thicker material than the other, but the one that runs on the thin material, which is the finicky machine, it also has something that we're going to be connecting to it that it actually can do multicolored prints without having to change things out. Yeah, Steve's been really excited about this.
I want to do Pizza Bird on it.
We're gonna 3D print the pizza bird. If you guys weren't here for the first 2 lessons that we did, so Steve taught, oh my goodness, we did some photogrammetry where we can like take photos of an object and then make it into a 3D object and then bring it into like a game like Unity and make it as like an object in there. So we 3D scanned some stuff, and during the process of the 3D scanning, Steve had 3D scanned.
Created a Pizza Bird.
Yeah, he created a pizza bird because he 3D scanned some pizza, but he had just 3D scanned the bird that's over here. So imagine a slice of pizza mixed with this adorable bird. Luckily, the color scheme matches, so that's nice. But when it became one, the pizza bird was coming out of the pizza because Steve had taken accidentally a line of photos from the other photo set and put it into the mesher. So when it cooked them together, it was like, yeah, this is what you built. And we were all looking at it being like, why is the pizza so weird?
So it's someone, and anybody can come in and, okay, because my program is data analytics. So
Yeah,
it's not,
absolutely.
not strictly.
No,
programming.
it is for any program.
Okay.
So anybody can come in and we'll set stuff up. I'll show you how to design for the laser cutter if you want something laser cut. I'll show you where you can get free stuff for STLs. I can show you a bunch of really cool YouTubes on things like building with Blender. We learned Blender last week. So a little bit of Blender. We learned how to take the things we 3D scanned and clean them up. So that's a really big skill to learn how to do, especially when you need to make sure that like just the bottom is flat. To make sure that when you 3D print it, it's not trying to build it in the air. To which, to be fair, I tried that before.
Which slice and software?
I use Cura. We also have something called Canvas for the multicolor. Once that gets set up, I had it half set up, and then we had a big tour coming through, and I just had stuff everywhere, so I just sort of packed it back into its box and tucked it underneath the counter. But it'll be coming back out. We usually have a co-op position in this room as well. So during that co-op position, yeah.
So what I would have really liked to comment that Blender, when you like, did you got the Blender?
We
class?
did.
Oh, cool.
Yep.
Is it
How do you even get the So, how do you even get the notifications? Because like I did not know that that class was going on.
Yes, so our notifications are sent through Eventbrite. You can also find on our GC HVAC if you follow us on Instagram. If you follow the Barrie GCSA, so this campus here, all of those areas they'll pop up as like an event happening. They'll either share it they usually share it in their stories. We share it as like a post, and then if you subscribe to our Eventbrite, which I can get you the URL, which is how you got here. If you follow us on there, every single time we add an event, it'll send the event to you. So it'll send, hey, HVAC has just added a new event. You should check this out. So that's the easiest way, because then you just get an automatic email every time I make an event. It'll send you an email, and you can sign up right away. Have you decided if you're coming to the hackathon or not?
Not yet.
Not yet?
I was just thinking about volunteering for in that hackathon, but like I still don't know how I can apply for that. So.
Yeah, that's on our Eventbrite as well. So if you were able to get here, then you're able to apply for the hackathon. If you want to volunteer, we're going to be doing volunteer information depending on if you work through the peer mentors or the GCSA, we can have you as volunteers, or I think through the International Center, as long as you're like a staff member, so we have you as like an easy volunteer. And if not, how are you doing over there? Good? I like that. All right. So we can have you as a volunteer there. But I would suggest coming to enjoy it because it's a lot of fun. It's even if you don't know much about VR, you're gonna have a blast. You're gonna meet awesome people for networking. You're gonna meet like new people, just like a couple people met today. It's pretty awesome.
Can you just come if we even do not participate, just to be here?
Yeah, we've had a couple students who have just come for the food.
Not for the food, to just see what other people are doing and try to just grasp some idea if possible.
Yep, that's exactly what we've had students who have just been like cheerleaders for other teams. And just like they came, there's two students, they were so hilarious. They ended up winning one of the prizes for being, I think it's like best hackathon attendee or something. They came to all of the little workshops, they tried out all the fun rooms that we had. And at the end of it, they were just happy that they had experienced, met people, they had fun, and then they ended up winning a prize for best hackathon attendee because they were like pumping up other teams, and like when they were coming on stage, they were like, yeah, you got this. So it's pretty good, it's pretty fun, just to like come and attend and like experience the hackathon itself, because it's a little nerve-wracking going when you don't know, like, I didn't know anybody for my first one, and then I realized that a couple of my friends who I had just met in class, they were like, they appeared there, and I was all like, I know you. This is great. Do you want to work with me? And at that time, we were great friends, and they were like, maybe. Which challenge are you going for? So then we based on which team we went on, based on which challenge we chose. So if I really wanted to help the homeless, I would go for the homeless challenge, and then I met a team who worked with that. I ended up working on a team where we were trying to figure out a way to make a downtown Barrie points card. So you could like gain points from each place you went downtown, and each thing would be worth a certain amount of points, and you'd be able to like gather those points and spend them at different shops. We had a pretty good idea. We sort of based it off the air miles, and it was done using cryptocurrency like that, the blockchain technology.
So how many teams are usually there? Like teams of 5, right?
Yeah,
5.
yeah. So far we have 46 people signed up. We're sort of gonna cap it around 60, just so we can make sure everybody gets food. An important thing again. And once we have it all sort of like set up, you guys will split off into your teams up to 5. So some teams are teams of 2, some teams are teams of 3, teams of 4. It's all good. We don't go over 5 because we usually have our prizes. We buy 5 of each thing. So that's like the maximum, unless one team member is totally cool with not getting a prize, but I feel like I wouldn't be. They'd be like, yeah, okay, everybody gets a prize except for you, Virginia. You are our least helpful member, and you don't get a prize. You cry. But yeah, so it's a really fun time, and I enjoy it when I go. So I wanted to make a cool experience for you guys to have a fun experience too. So
They're an interesting event if you've never been to one. This one's around coding or VR, but they do have them that are more generic around change making in general and stuff. It's always good to experience one, and then you kind of know what to expect for the next one, whether it's really the topic or not.
We did another one with the city of Barrie that had nothing to do with coding. It was just trying to like help the housing market and like figure out how people of certain wage levels could like figure out how to live in Barrie and what acceptable housing was, and how we could kind of like bring those things to like a normalized level. So that was a good one too. And that's like on that Major League Hack site, that MLH.io, you can find tons and tons of different hackathons on there. So, and if you're interested in whatever type of coding you're on, there's probably a hackathon on there. And a lot of them you can attend online now, so you don't even have to get to the venue.
Being at the venue is a better first-time experience than the
Yeah.
remote one.
Yeah, we
Just
had
like
a couple.
teaching and learning sometimes is better in person. You can do it remotely, but
And it's strictly like restricted to students, this type of talk?
Yeah, so it's students and some alumni as well have been pondering coming. So it's students and friends of Georgian. So if you have friends from another campus or another area, they're allowed to come with you onto your team.
so they don't need to be a Georgian student,
They don't need to be a Georgian
but they
student.
have to be over 17 or 18.
They have to be over 7. I think it's 18.
18 or older, but they don't have to be a Georgian student.
Yeah. And then if you get the bonus if you are a Georgian student, you can use the showers, but we were told the other day that if you're not a Georgian student, because you don't have the proper passes, you can't use the showers. But we will have like tiny toiletries and stuff like that, so we have bathrooms in any building that we can take over for
Right,
that.
maybe 30 hours, right?
30 hours straight. We'll have like napping zones and girls' room and guys' room for napping, and then we'll have coding rooms all night. Volunteers going around doling out candy to people.
24-hour coffee.
Yeah, it's almost 24-hour coffee. The coffee will leave at 11, I think, and then it'll come back at 8 in the morning, I believe. So bring some thermoses.
Yeah,
And we'll
we'll
fill
be
up the
able to take
thermos
up
for
that
overnight.
mixture.
Yeah. And we've got a mixture of like caffeinated and decaf. So I'm a decaf girl, so they have one pot coffee just for me.
Decaf coffee, stay up.
I actually don't sleep, so
Wow.
I just live awake. So having caffeine, when people are like, I need caffeine to stay awake, I'm like, I don't know how I would live with caffeine. I wouldn't sleep for weeks, I would assume. All right, do you want to like wrap up the night then? We're hitting our 6:30 mark.
I mean, we've already hit 6:30, so.
I just see that you're tired now.
Yeah, I've only had like 3 hours of sleep as well.
Oh dear. All right, well let's give Victor like
Just
a round
a
of
lot,
applause.
just like-
That was, I have been listening to you teach the whole time, and you did a great job. So
I don't think
just
so.
let you know, yep. Round of applause. I will be seeing Victor again, and he'll give it.
That'd be great.
Yeah, I'll be one of the people who can actually assist with you. It's like so. Yeah, so I'll probably be in a much better state because I'm going to be doing one-on-one with people rather than actually trying to teach. So yeah, I'll be able to kind of get through a lot more maybe and help out with some of the problems.
Yeah, that's going to be a big one because we'll have moments like these where it's like, what did I miss? And Victor will be on the ball and he's like, you missed this section right here.
Yeah, because
You missed a bracket.
Because I missed so much talking like through this because I had notes. It's like how I needed to, it's like what I needed to actually go through. It's like what you actually need to do before you get to another point. And the other thing is that this is Unity is like I said, is such a there's so much to cover in Unity. Normally, it's like to learn Unity, you do an entire semester of this stuff. So like one class of 2 hours, 3 hours would be nothing but coding, just on its own. So I had to try to condense this down to 2 hours, and I started to miss things after a point, and it just threw me off after that.
So you had to explain the 4 days of coding.
Pretty much, yeah. Like coding is one of the more important things in it. And but really, it's like actually the main thing I can say about coding is mostly problem solving. It's mostly thinking about what your problem is and what you want to achieve, like what you have and what you want to achieve. So the question then becomes, it's like, well, how do I get to point B? Once you know different. Not even just the basics. Once you kind of understand the engine, once you understand is like what you can do, you can start thinking about all the different ways of how you can achieve your goal. Because there's lots of different ways to do it. You don't necessarily have to know every single thing within the engine. There's so many things in this engine that I've never done before. It's like I can tell you right now, if I right click, if I go into create. First off, animations is something that doesn't really even that I don't really even do. But even just like looking at some of these lighting settings, like not even just for the lens flare, but it's like even creating avatar masks, or creating blend trees in this. Even though I have done blend trees in Unreal, blend trees in Unity is something I haven't done before. So. It's like, yeah, I wouldn't even know where to start with that. It's like there's so many things that you can do with it, doing this, and yeah.
Unity support like ray tracing, or it's not yet?
Oh, it does support ray tracing. Yes, ray tracing is a very important. Yes, there is ray tracing in this. It's a very important one. Actually, you know what? I'm going to just really quickly open up the other project. Just to be able to show you. Oh, first off, if you want to be able to create a very simple VR project, like. Using the Unity toolkit. So Unity created a toolkit which already can get you started in VR. So it gets you started with all the with being able to use hand animations, being able to use your hands, being able to connect the headset, as well as a couple of other things like teleporting, the movement, like all of that is already done by Unity. So they created a toolkit for that. So if you want to do that as well, what you have to do is you have to go to where is this edits? You have to go into packages, import back. I'm trying to remember which select dependencies reference import back. No, it's not packages. Hold on a second. It's the package manager. There we go.
Oh, yeah, look at your button.
You go to. Oh.
We're still live streaming.
Oh, I know. We'll kill that in a moment. There we go. So here we go. Our package manager. So when you go into the package manager, you can go to add package by name. And then here you'll write out com.unity.xr.interaction.toolkit. You can search this online as well, like the Unity interaction, Unity XR. Basically, just search Unity XR, and you'll find it as one of the main things. There's Unity documentation for it. Again, it's created by them. But if you add this toolkit, you will get this entire sample scene right here. Where do they have demo scene? There it is. You'll get this entire sample scene right here, which can get you started in VR. Yes, you will need a headset for it to be able to see it, but maybe there will be one available here in the Maker Lab at a certain point. Don't know. But it will get you all of the. It will give you all of the different objects you will need just to get started on it. All of it is already connected, so you can just grab the entire prefab of the complete XR setup. You could just drag it in, and it will create your character. Opening that up, you'll have everything already you need for the for your hands. So you'll notice you have. Let's see if we can zoom in. Yeah, kind of. There we go. So yeah, we have well, this is slightly different. Oh, it's using controllers, not hands. Right, I forgot. I used a different hand thing. But yeah, okay. But yeah, you'll have the controllers. It will have already the ray interactors already there. You'll be able to do the teleporting. So this is really like if you wanted to just get started purely on just a very quick on a VR project and build out what you want to do afterwards. Like you could just start with this toolkit, try to learn this toolkit. There are a couple of Unity tutorials online that go really in depth about this kind of stuff. And again, it's once you understand the basics, like once you understand like the very basics of code, you can then start following along with a lot of those tutorials because they're very simple to do. A lot of people sometimes even just go really in depth with them. One thing I can actually show you really quickly is the where is it? We'll go to the sample scene. Yeah, don't save.
So are we expected to like create a scene for the problem that we solve? Like the
Yes, so the scene, yeah, see, this is one of the things I forgot to say. The scenes is almost as if it's a level within your projects. So you can have different scenes. For example, a scene for your main menu, and you can have a scene for level 1, level 2. It's like all sorts of things. Your scene is basically it's like it's like the level of a game, and you can have. You can assemble it. You can assemble them differently, and then kind of move from scene to scene. It's like as you kind of progress through your game. So, well, in this one, I have ones where there are hands created for them. Actually, you know what? Like I said, yeah, we've run out of time. It's just going to get too complicated at this point now. So. Yeah, when we do the hackathon, I can help one-on-one. I can't do this.
You'll get there.
Eventually, yeah, maybe.
One step at a time.
All right, well, we'll stop this one.
yeah, it's really difficult to talk 3 hours straight.
It's hard when you're thinking about a lot of things and you know
It's just a lot,
you
like, I was
forgot something
surprised.
as well.
Like